Welcome! In this video we're going to be looking at the chain rule, which is a rule that you can use to find the derivative of quite complicated functions, especially those where it looks like one function has swallowed up another function. Look to the left of the screen and you'll see I have the rule written out in full. I'm going to be talking about y's and x's here, not just functions, to make it quite easy. So on the one hand, on the left side over here we have a simple y, and it equals, if we had something like y is equal to x squared plus the square root of x plus a half. This is the function part and this is the y equals part. So that's the kind of the language I'm using to the left of the screen. So y equals one function having swallowed up another function. And the chain rule is dy dx is equal to the derivative of the swallowed function multiplied by the derivative of the swallower function evaluated at the smaller function. This is a mouthful to say and it's even more difficult to understand. So I'm going to do an example just to the right of a common problem that can be solved by the chain rule. So say I had y is equal to e to the power of sine of x. This looks like the sine of x function, which usually looks like this. It's just sitting out in the open. It looks as though it's been swallowed up by the exponential function, which sits usually just with an x up there. So straight away I'm going to say, okay, the big function, f of x, is equal to e to the x, and the swallowed function, g of x, is equal to sine of x. And I'm going to put this down, y is equal to f of gx, and I'm going to explain why this is. If I said y equals f2, most people would say, okay, so I'm going to the function f of x here, and I'm plugging in a 2 up here, so it's e2. If I said, therefore, that y is equal to f g of x, you should say, okay, well, it's the f of x function up here, but where x was, I'm going to put g of x. This is equal to e to the power of g of x. And then the last step is to simply say, okay, well, instead of writing g of x, I can just write sine of x. So y is equal to e sine x. That's the same thing I have written up here. And that proves that y does in fact equal f of g of x. So from here, we can apply the beautiful chain rule. We need to find out a few things. We have f of x equals e of x, and g of x equals sine x. To fill in this formula up here, we need to know what f dash of x is and what g dash of x is. So we'll start with f dash x, and f dash x means what is the derivative of e to the x, and it's the same thing, e to the x. G to the x, we need to find g dash x. What's the derivative of sine x? That's cos of x. And there's a video on that if you want to know more. So now we have everything we need to fill out this formula. We know that y equals e sine of x, which is equal to f g of x. So dy dx is equal to g dash x. Where's that? That's over here. So cos x multiplied by f dash. Where's f dash of x? Over here. So the f dash function, but instead of f dash x, which is just equal to this, we need f dash g of x. So just like we said before over here, we go to where x would have been and we replace it with g of x. So it's e to the power of, change that to green, sine x. And that is our derivative there. So it looks quite different to the function we had up here. It's got a cos x out the front. Let's do a second example to firm up our understanding. Say we had, we'll say y is equal to, we'll do the other way around, that'll be interesting. Sine e to the x. In this case, the big function, I'll draw a line across here, the big function is sine of x, and the little function is e to the x, and y is equal to f of g of x. Therefore, dy dx is equal to, well, first we go just to the left and we say f dash x is equal to cos of x, g dash x is equal to e of x. So dy dx is equal to g dash x over here, e to the x, multiplied by f dash g of x. So it's the f dash x function, which is cos of something, but instead of just writing x here, which would be wrong, we need to plug in the g of x function. So that's up here, times cos e to the x. So we have the derivative here of this function. The way I was taught this rule wasn't with this formula here, because our teacher thought he was just throwing a function at us if he were to give us this function that wouldn't make sense to us algebraically. So I'm going to teach you to the right the method that was taught to me, which I used all throughout the exams, and I thought it was much easier. Say we had the function y is equal to log e tan of x, and just pretend the domain of x is sorted out so this is actually defined. I'm going to say let u equal tan of x. So u equals the swallowed up function. And if you're smart, you'll notice that this is a lot like saying g of x over here is equal to tan of x. But we'll keep it at u for now. So then you go below and you say, okay, if u is equal to tan of x, then y is equal to log e u. And we'll put u is equal to tan of x here. And then I'm going to say what dy du is. And again, if you're paying attention, this dy du is very similar to saying, okay, what is f dash x? But we'll stick with u for now. Dy du is equal to 1 on u, and du dx is equal to 1 on cos squared x. If these derivatives aren't making any sense to you, go watch the videos on how to derive log ex and u equals tan of x. So now, why are we doing this? I'll put this in red because this is the key step. I'll write up the top here. Our goal was to find dy dx. We want to find the derivative. So we wanted to find dy dx. But all we have is dy du and du dx. So we say how we find dy dx is by multiplying dy du by du dx. And we can treat these as fractions. If it's du down here and du up there, we can simply cross them out, leaving dy dx. I'll write that twice. So if we multiply dy du by du dx, we will get the derivative of this function up here. So let's try that. We've got dy du, which is 1 on u, and we've got du dx, which is 1 on cos squared x. So in the end we get 1 on u cos squared x, and the final step is to say, okay, it's no use having u hanging around because u is something we've invented. It wasn't included in the original relationship. So we replace u with what it was assigned to, which was tan of x. So this is 1 on tan of x cos squared x. And I'll put this in purple because this step could be optional in an exam. Tan of x is equal to sine x on cos of x. That's just the identity. So this is equal to 1 on sine of x on cos of x times cos squared x. And I can cross out this lower sign and take away a power 1 there. So this is equal to 1 on sine x cos x. And that is the chain rule. I encourage anyone who's learning about the chain rule to do exercises, because this isn't something that takes a long time to master. But like I said before, this is not a formula that is just going to fall into your head naturally. It's a bit like the quadratic formula. You've got to memorize it. Highly encourage you when you start off to use this kind of working here, because I think it's much harder to forget this method than this method over here. Well, I suppose if you had a cheat sheet, then this would be easier. Find out what works for you.